A 2 kilo rigid block in static equilibrium is attached to a massless cable pulley system, and we're asked to find the force in cable BC. So what we'll do first is take a free body of the block and draw all the forces acting on it. Where the force of weight acts through the center of mass of this block. Now because we're asked to find the force in cable BC, we'll take a sum of torques about a point where the line of action of the unknown forces passes through. So therefore these forces produce no torque about this point. And by rotational equilibrium, the sum of torques about point P must be 0. And we can resolve this force into horizontal and vertical components, where this angle is 30 degrees. And you can use the right hand rule to determine the torque contributions from each of these forces. So for the force of weight, it's going to produce a counterclockwise torque with a moment arm of 0.1. And similarly for the other two forces, and for the horizontal component of BC, that's going to produce a clockwise torque, so that's negative, with a moment arm of 0.2. And the vertical component is going to produce an anti-clockwise torque and has a moment arm of 0.3. And the net torque must be 0 for static equilibrium to be satisfied. And now you can solve for the force in cable BC and post your answer in the comments.